Hello, my name is Carl Cook, and I'm President and Chief Technical Officer of Biocomp Systems. And thank you for watching this video today. And I want to give you an introduction to developing for Dakota 3 from the standpoint of how is this architected internally? What can you do, and how is it structured? Within Dakota, you can, if you're so inclined and skilled, development's not for everyone, you can create add-ins for initializers, adapters, bot performance, movers, trading systems, model mergers, and evaluating swarm performance. So an initializer is code that takes the trading system's parameters that are being walked forward adapted and initially puts them somewhere into their ranges, whether that's randomly or in some structured form. Then comes next is the adapters, which based on the bot's performance, typically, those parameters are moved. And bots can look at each other, they can move towards the best, or perhaps do hill climbing on a better performance. Oh, look, I moved this direction, I made more money, so I'm going to keep moving that direction. So adapters move those parameters in their parameter space within their ranges. Next comes bot performance, which is given these parameters and the trading system calculates a signal that the bot now has, how good is that signal? And that can be used to say this bot's better than that bot, or that the performance improved by making this change. So it's a number that goes on a bot's and its parameter values for that trading system. Movers move bots from swarm to swarm. Trading systems are what generates the signals. So you get data coming in and you calculate some number that's a signal. Let's say if the short-term moving average is above the long-term moving average, you issue a 1, otherwise maybe a -1, or you calculate some number that's positive or negative. Positive being buy or go long, negative is sell or go short, 0 means stay pat, that type of thing. Next comes model mergers. All these bots have all their signals. How do you combine those signals together to provide it to the Dakota user interface to show it in a display, and it becomes your trading signal? So it takes all the bots, perhaps looking at their performance, but certainly looking at the signals that are coming out of each bot and its trading system, combining those together, maybe just taking a simple average, and then providing that to Dakota. And finally, the swarm performance is the same as the bot performance. It's basically evaluating how was this swarm performing relative to all the signals that are being merged together from the bots. So how do you do this? Well, you have your code, and it's implementing one of those capabilities. And we thought long and hard about it. And there's various ways to add in code within any architecture. And we chose to have you inherit a parent object. Another way is to inherit or to implement an interface. And implementing interfaces is very common within the software development community, but it doesn't provide you any functionality whatsoever. There's no default behavior. There's no add-in functionality in terms of functions. It's just a contract that says you must implement these interfaces. You must have parameters. You must have these functions, and they must be have these parameters and nothing else. And so interfaces, while nice for this purpose, have some gross shortcomings. So we decided to have you inherit a parent. And this parent object contains default behavior, which you then override and implement your own version of what's supposed to happen. And if you decide not to override something, then the default behavior occurs, and you don't have to worry about it. It just works. So let's say, for example, you create a trading system, a bot, that you don't care if you save anything that you've created. You don't create any kind of result that you want to save. You don't have to implement the load and save. Even though an interface would require you to implement load and save, you don't have to, because the parent object already does it. And if you want to save things, then you can override the parent's load and save functions. So it's very handy. Plus, that parent object contains a lot of functionality that makes things easier. Like, there's a very flexible moving average calculations in there, or WinZs, or all sorts of different things that are in the parent object, that when you inherit it, all of a sudden now you have access to all of that, and that makes it very nice. What you don't care about is that your code, which inherits the parent, and they become one, are sitting inside a proxy, and that proxy provides an interface to the Dakota operation. So the Dakota makes a call on the proxy. The proxy says, "Oh, look, I've got Billy Bob's code in here. I will, go call it in Billy Bob's code." And so the proxy also has some default behavior and a defined interface, which then links it into the rest of the Dakota operations. So that's just basically an overview from an architectural standpoint, and gives you some justification as to why we chose to have you inherit a parent to your advantage rather than implementing an interface or other mechanisms for doing add-ins. So in a later video, you'll see how to set up Visual Studio 2012 as the development environment for Dakota, and how you reference Intellect 3 architecture and then inherit the parent, and then you have all this capability available to you. So thank you very much for watching this video, and stay tuned for the next one on how to set up Visual Studio 2012.